Welcome to Regression Analysis tutorial. This is Dr. N. Mao, Professor of Information Systems. Regression analysis is a powerful tool that allows us to explore data relationships and also provide predictive analytics. In this tutorial, I will demonstrate how to develop a regression model, conduct the regression analysis in Excel, and interpret the results. A regression analysis starts with a research question. In simple regression, the generic question is, does X influence Y? Here is a graphical representation of that question. X is the independent variable. It's also called the predictor, indicator, or sometimes is explanatory variable. Y is the dependent variable, sometimes called the criterion variable or outcome variable. So let's look at a more concrete example to demonstrate this relationship. Here is from a trucking company's context. Any company that is in the business of delivery or transportation pay a lot of attention to the time it takes to deliver their shipments. This question hypothesizes whether miles traveled impact delivery time. Another example is, does price predict sales? The regression analysis can not only answer the question we hypothesized here, but also can help us make future predictions. So far, the examples here have only one independent variable. This is called simple regression. When we have two or more independent variables, that's multiple regression. To expand the previous trucking company example, in addition to miles traveled, the management suspects that the number of deliveries a truck makes can also impact the travel time. Here is the graphical representation of that. So we have two independent variables impacting the dependent variable y. So for the trucking company example, we have miles traveled and number of deliveries impacting travel time. So for the sales model, we added advertising. So this particular example means both price and advertising can potentially impact sales. The overall objective of adding more variables is to try to capture more variance in a dependent variable. Using the same concept, we can expand regression into multi-level structural equation models. Here is the research model from a 2019 paper I published in Psychology and Marketing that examines the intention to adopt mobile payment. Using a multi-level structural equation model, we can identify the interplays of various variables and their effects on mobile payment adoption. Let's dive in and learn how we can conduct a regression analysis in Excel. You will need to enable the data analysis add-in. This is not a default feature. If you have a Windows-based machine, you go under File, Options, and Add-ins. If you're using a Mac, you need to go under Tools, Excel Add-ins, and select the Data Analysis add-in. Let's go to Excel. So here's the data set from Chapter 7.5. The travel time here is in column E. Miles traveled is in column B. Number of deliveries in column C. We also have an additional variable called gasoline consumption. We will examine that a little bit later. Let's start with a simple regression where we hypothesized miles traveled impacts time. So we call that regression model 1. It's always a good idea to keep track of the models you are developing, document it. So miles for this one impacts time. Okay, so this is our first regression model. Go under the Data tab and find your data analysis. Regression is towards the bottom, so if you scroll up and down, you will see the different kinds of analysis available. So select regression, click on OK, select the ranges of your data. We're going to start with the dependent variable, and that will be in column E. If you scroll towards the bottom, and it will be until 301. Okay, you can select that way, or you can just go in there and type in the Pacific range and check our column B is where the independent variable miles. Since we included the titles of the columns, so we need to check the labels, and we can keep the confidence level at 95%. The output range can be put into directly in this particular worksheet or into a new worksheet. Since we have a large data set, we're going to put it into a new worksheet and click on OK. It will put into a sheet right before that particular tab. We'll look at how to interpret the results a little bit later. For multiple regression, if you have two or more variables, it's always a good idea to actually run the correlation matrix first to rule out any problems with multicollinearity. So we have three variables: miles, deliveries, and gasoline consumption. So let's put that into a correlation matrix with your dependent variable. The correlation matrix is also under data analysis, and it's towards the top, the fourth option, correlation. Click on OK, and you'll be able to select the range. So you can select range B to E, and we're going to modify that to E301. Selects all the independent variables as well as the dependent variable. And click on OK. So here's our correlation matrix. It's important for you to investigate correlation coefficients between the different variables. Specifically, we can see between miles and gasoline consumption, we have a very, very high correlation of 0.95, almost near perfect correlation. So the question becomes, do we include both miles and gasoline consumption into our regression model? If we examine further to see how they correlate with our dependent variable, miles has a little bit higher correlation at 0.69 than gasoline consumption at 0.65. Therefore, the conclusion will be to only include miles, which is a better correlated variable, and delivery into the multiple regression model. Come back to our data and perform the multiple regression. So go to Data tab again, under Data Analysis, towards the bottom, Regression, and OK. The dependent variable remains the same. For the independent variable, we will include from B to C. So the only thing we need to change is the range from B1 to C301. And everything else will remain the same. And when we click on OK, we're brought to our multiple regression results. And make sure come back and make a note. Regression 2 is miles plus deliveries and impacting our time. Let's take a look at how do we interpret the results of regression analysis. Let's start with assessing the overall model. There are two key statistics we need to evaluate to look at the overall model fit. First is the variance extracted. This helps us to understand what percentage of the variance has been explained by the independent variables. The simple regression model explained 48% of the variance, which is actually pretty good. In social and behavior science, anywhere above 25% is a reasonable assessment. Next one is the ANOVA model assessment. And we need to look at the F statistics. And for this, we look at the p-value for the F statistics. And in this case is 0, which is less than 0.05. That indicates the overall model is significant. Together, the adjusted R-square and the F statistics reveal this is a good model fit. The intercept, which is also the slope, is this placeholder variable captures variance in time associated with other variables that are not in this particular model. And the miles coefficients here is important to look at. This is a positive, we can see review here. And positive coefficients means that this variable is positively associated with the dependent variable time. So in this case, the miles actually influences time. So the larger the coefficients, the more influence a variable has on time here. We also need to assess the variable in conjunction with the p-value. The p-value is 0 in this case, which is less than 0.05, indicates that the coefficient is significantly different from 0. In other words, these variables have an effect on time. And there are other ways of saying it. For example, miles has a significant effect on time, or miles influences time, or miles impacts time. Let's take a look at the results for multiple regression analysis. Let's start with the adjusted R-square. In this model, we can see explain 82% of the variance of time. Comparing to the simple regression, we have a 34% increase in the adjusted R-square. The overall model also is significant in the multiple regression result. And here we can see the additional variable deliveries has a significant impact on time. So the more deliveries, more time it takes. The p-value for this particular variable is also significant at 0. And we can see miles remains significant in this model as well. So both independent variables are significant in this multiple regression model. So the question becomes, which model is better? The simple regression model captured 48% of the variance, compared to 82% in the multiple regression model. Therefore, the multiple regression model is superior. So to summarize the interpretation we just looked at, from a technical perspective, we examined R-squared, the model p-value, the regression coefficients, and their significance level. But we also need to go further to look at what are the business implications. What should a company focus on based on these results? So in order to reduce delivery time, we absolutely have to look at both miles traveled and the number of deliveries. So what does it mean for the stakeholders then? Well, for the delivery truck drivers, we can support them with better directions to reduce the number of miles traveled for them. And also we can come up with better logistic technical solutions to help them consolidate the shipments into as few number of deliveries as possible. Those kind of solutions can ultimately lead into reduced travel time. So at the end of the day, the business implications is the ultimate goal of solving problems. So make sure as you analyze any data with regression, you have to take the step to explain from the business perspective. I hope you find regression analysis to be powerful and exciting. So thank you for learning regression with me. If you have any questions, please let me know.